So at first we are going to discuss about the term acceleration. Acceleration is denoted by symbol A, and the definition given here, the rate of change of velocity is called acceleration. Now try to understand this term. Suppose a body started its journey from A and it was moving with velocity u. After time t, the body reaches position B and its velocity becomes v. So a body started its journey at A, velocity was u, at B velocity becomes v and time taken t. And acceleration is the rate of change of velocity. So we can write like this: acceleration is equals to change in velocity by time. Change in velocity by time. And here in this explanation, u represents initial velocity. V represents final velocity. U represents initial velocity, V represents final velocity, and T represents time taken. So, by definition we know that acceleration is change in velocity by time. So, U is initial velocity, V is final velocity. Suppose that V is greater than U. So, we can write here change in velocity. For that we can write here final velocity, that is V, minus initial velocity, that is u, by time, that is t. So we can write down the formula here, v minus u by t. So if I ask you what is the main formula for acceleration, acceleration is v minus u by t. And whenever we use the term acceleration, it denotes increasing velocity. With time the velocity keeps on increasing, then the term acceleration is used. If the velocity keeps on decreasing, then the term retardation is used. So generally when we use the term acceleration, we think of increasing velocity. So the formula A equals to v minus u by t. Now SI unit. SI unit of acceleration. Acceleration is change in velocity by time. So SI unit of acceleration, change in velocity by time, you know that A is equals to change in velocity. So velocity unit is meter per second and time the unit is second. So it will be meter per second square. So if I ask you what is the SI unit of acceleration, meter per second square, or you can also write like this, meters second to the power minus 2. So if it is asked what is the SI unit of acceleration, it is meter per second square. And if it is asked what is the CGS unit of acceleration, it is centimeter per second square. Okay. So if I ask you what is acceleration, the rate of change of velocity is called acceleration, and the main formula to calculate acceleration, E equals to v minus u by t. One thing you should know, acceleration is rate of change of velocity, and since it is rate of change of velocity, it is a vector quantity. So what kind of physical quantity is acceleration? It is vector quantity, and the direction of acceleration is same as the direction of velocity, we can say. So note down this formula and will be required in solving numericals. Now we are going to discuss the second term of this video, and the term is retardation. As you can see here, I have written minus a. Retardation is negative of acceleration. Negative acceleration is called retardation. And when a body moves like this, it's at position A, its velocity is supposed to be 10 meter per second. After 2 seconds, it reaches position B, its velocity becomes suppose 8 meter per second. After 2 more seconds, it reaches position C. Its velocity is supposed to become 6 meter per second. So, with respect to time, the velocity of the body keeps on decreasing. And in this case, we use the term negative acceleration. Negative acceleration is called retardation. So, we can say that the body is moving under retardation. Okay. So, if I ask you what is retardation, negative acceleration is called retardation. और जब एक बॉडी एक्सेलरेशन में होता है, इट्स वेलोसिटी विल कीप ऑन इंक्रीजिंग विथ रिस्पेक्ट टू टाइम. जब एक बॉडी रिटार्डेशन में होता है, द वेलोसिटी ऑफ द बॉडी कीप्स ऑन डिक्रीजिंग विथ रिस्पेक्ट टू टाइम. सो इन दिस केस, in this example, the body is in acceleration or retardation. The body is in retardation. The formula to calculate acceleration and the retardation, formula is the same. The formula is v minus u by t. But while doing calculation, finally you will have to find out minus a. Minus a will represent what? Retardation. To calculate retardation, you will have to find out minus a. I can explain with this example here for motion from A to B. If you look at this example, A से लेके B तक का motion में starting velocity यानी initial velocity का value है 10 meter per second. So here u is given what? 10 meter per second. We are considering motion from A to B. So u 10 meter per second. V 8 meter per second. Time taken from A to B is 2 seconds. So what is the formula here? A is equals to V minus u by t. V, what is the value of V? 8 meter per second. U 10 meter per second. Time 2 seconds. So it is minus 2 meter per second by 2 seconds, and you will get minus 1, and the unit is also the same, meter per second square. So you are getting A as minus 1 meter per second square. Therefore minus A is equals to 1 meter per second square. So if I ask you what is retardation, in this case the answer is 1 meter per second square. So to calculate retardation, what you are going to find? You are going to find minus A by using formula. Okay, and its SI unit, if it is asked, SI unit of retardation is meter per second square, can also be written as meters second to the power minus 2. If I ask you what is the CGS unit of retardation, CGS unit is centimeter per second square. And retardation is also a vector quantity. It is also a vector quantity, since it is also change in velocity by time taken. But here velocity keeps on decreasing with respect to time, but in acceleration velocity keeps on increasing with respect to time. So we have already discussed the terms like acceleration and retardation, and now we are going to discuss meaning of another term, uniform acceleration. So what is uniform acceleration? First try to understand here a body is moving in a straight line. A body is moving in a straight line such that at position A its velocity is 0. At B the velocity becomes 2 meter per second. At C the velocity becomes 4 meter per second. At D velocity becomes 6 meter per second. At E the velocity becomes 8 meter per second. So the velocity of the body keeps on increasing. Now look at the time taken here. 0 to 2, suppose the time taken is 2 seconds. Then 2 to 4, again time taken is 2 seconds. Then 4 to 6, 2 seconds, 6 to 8 also 2 seconds. So with respect to time, the velocity keeps on increasing. Now look at the acceleration in each part. If you find out acceleration in this part, A is equals to V minus U by T. So agar acceleration we calculate V minus U by T, so it is 2 meter per second minus 0 meter per second by time is 2 seconds. So 2 meter per second by second, you will get 2 meter per second square. So we are getting acceleration from A to B as 2 meter per second. If you do the calculation for B and C, you will get the same answer, 2 meter per second square. From C to D, from D to E, the same answer you are going to get, 2 meter per second square. So for this body, acceleration at any point remains constant. During motion, acceleration remains the same. When a body moves like this, its acceleration is called uniform acceleration, and besides that, the body should move in a straight line. If direction changes, we say that acceleration also changes. So look at the definition here. Uniform acceleration. The acceleration of a moving body is said to be uniform acceleration if the rate of change of velocity of the body is constant and the body is moving in a straight line. So this is the example to understand the term uniform acceleration. In the next part of the video, I am going to solve so many numericals, but I will solve one numerical for you and one numerical will be given to you for self-practice. So one I will solve, one you will have to solve. And those numericals which will be given for self-practice, their answers will be given in the last part of the video. So at first, you will have to try to solve that numericals along with the video, and finally you can check your answer from the last part of the video. And you also wait for a challenge in the last part of the video. One challenge question will be given to you. You will have to send the answer of that particular question by tomorrow, 30th March 2020 by 2 p.m. If you can send your answer quickly, the name of the first 5 correct entries, their name will be published in the next video of the same topic, that is part 4. We are going to solve first numerical, and the question is given here. The speed of a car changes uniformly from 2 meter per second to 12 meter per second in 2 seconds. Calculate the acceleration produced. This is a simple question. If you look at the solution, you can easily understand. In this particular question, the speed or velocity changes from 2 meter per second to 12 meter per second. तो पहले speed और velocity कितना था, 2 meter per second. तो initial velocity, starting velocity, symbol is u. U is 2 meter per second and v is 12 meter per second. V represents final velocity. तो पहले 2 meter per second, बाद में 12 meter per second, and the time taken 2 seconds, and you are asked to calculate acceleration. You know the formula. What is the formula? Formula of acceleration: A is equals to V minus U by T. Acceleration is equals to V minus U by T. So final velocity given here, 12 meter per second. Initial velocity given here, 2 meter per second. Time taken, 2 seconds. So it is 10 meter per second by 2 seconds. So the answer is 5 meter per second square. So the answer is 5 meter per second square. Simple question. The formula used is A equals to V minus U by T. Now question number 2. Question number 2 is for your self-practice. Question number 2, the velocity of a body increases uniformly from 20 km per hour to 60 km per hour in 6 seconds. And you are asked to calculate the acceleration produced. While solving this numerical, you have to consider the units. Time is given in SI units, seconds, but the velocity, it is not given in SI unit. So you will have to convert the units from kilometer per hour to meter per second, because time is given in second, and then you try to calculate the answer in SI unit, that is meter per second square. Now question number 3 that I am going to solve for you. The question is, the velocity of a truck decreases uniformly from 20 meter per second to 5 meter per second in 3 seconds. Calculate the retardation produced. So look at the solution. Again, the simple question. Initial velocity is 20 meter per second. Final velocity is 5 meter per second. Time taken is 3 seconds. You are asked to calculate retardation, that is negative of acceleration. And we know the formula. I told you that formula to calculate acceleration and the retardation are the same. So A equals to V minus U by T we can write. So A is equals to V, final velocity here, 5 meter per second. Initial velocity is 20 meter per second. And time taken is 3 seconds. So A is equals to minus 15 meter per second by 3 seconds. So A equals to minus 5 meter per second square. Therefore, minus A is equals to 5 meter per second square. 5 meter per second square minus A. Therefore, we can write retardation minus A is 5 meter per second square. Okay. Question for your self-practice. Question number 4. A bus was moving with a speed of 54 km per hour. On applying brakes, it stopped in 8 seconds. It stopped. That means final velocity is 0. Calculate the retardation produced in SI unit. And SI unit of retardation you already know. So you have to find out answer in that unit. Now question number 5 is related to average speed. The question is, a bus travels first 80 km with a speed of 40 km per hour and next 100 km with a speed of 25 km per hour. Calculate the average speed of the bus. You will have to calculate the average speed. And what is the formula to calculate average speed? It is total distance covered by total time taken. So we'll try to solve this numerical. So here it is given, the bus covers first 80 km, let this be S1, with a speed of 40 km per hour. Then next 100 km, we can consider this is S2, with a speed of V2 with a speed of 25 km per hour. You are asked to calculate average speed. To calculate average speed, you need total distance. So given here S1, S2, you can easily find out total distance covered. But time for the first part and time for second part, it has not been given. So you will have to find out time for first part and then time for second part. You will have to add the times, you will get the total time, then you can easily find out average speed. Now look at the solution here. First case, we can write V1 is equals to S1 by T1. V1 is equals to S1 by T1. Here speed is equals to distance by time. So T1 is equals to S1 by V1. So T1 is equals to S1 is 80 km, V1 40 km per hour. Therefore T1 is 2 hours. So T1 is 2 hours. Second case, we can write V2 is equals to S2 by T2. From this we can find out T2. T2 is equals to S2 by V2, and S2 is 100 kilometer and V2 is 25 kilometer per hour. Therefore, T2 will be 4 hours. T2 will be 4 hours. So we calculated timing for first part, timing for second part. Now the formula for average speed. What is the formula for average speed? Total distance covered by total time taken. Total distance covered S1 plus S2. Total time taken T1 plus T2. So S1 80 kilometer plus 100 kilometer by T1, it is 2 hours plus T2 4 hours. So it will be 180 kilometer by 6 hours, and if you divide you will get 30 kilometer per hour. So the average speed of the bus is 30 kilometer per hour. Now question number 6 for your self practice. Question number 6 is similar to question number 5. You can easily solve, and question number 6 is a car travels 30 kilometer at a uniform speed of 40 kilometer per hour, and next 30 kilometer at a uniform speed of 20 kilometer per hour. You will have to find the average speed of the car. Okay, so you can easily solve if you have understood question number 5. Now question number 7. This pattern is very much important. Be focused and try to understand the solution of this particular question. A body covers one round around a circular park of circumference 176 meter in 4 minutes. Find the displacement of the body after 6 minutes. So first let us try to understand the question. Circular park, its circumference is given, and circumference given here. We know the formula of circumference 2 pi r, and circumference given here 176 meter. Find the displacement of the body after 6 minutes if it covers 176 meter of circumference in 4 minutes. So to complete one round around the park, the time taken is 4 minutes. Okay, so first we can do one thing. We can find out the number of rounds completed in 6 minutes. So number of rounds completed in 4 minutes is 1. Number of rounds completed in 4 minutes is 1. Therefore, number of rounds completed in 6 minutes will be 1 by 4 into 6, that is 1.5 rounds. So in 6 minutes, the time is 6 minutes, in 6 minutes number of rounds completed 1.5. तो अगर यहाँ से स्टार्टिंग पॉइंट है तो एक राउंड में एंड यहाँ पे, सेकेंड राउंड में यहाँ पे पहुंचेगा एग्जैक्टली एट द ऑपोजिट पार्ट. And if I join these 2 points, it is equals to diameter. If I join by straight line, it is the diameter. So number of rounds completed in 4 minutes 1, number of rounds completed in 6 minutes 1.5, and you are asked to find out the displacement. So we can say what from the figure? The displacement after 6 minutes is equals to diameter, and diameter is 2 into radius. Since circumference has been given, from that we can find out radius. 2 pi r is equals to 176 meter. So 2 into 22 by 7 into r equals to 176 meter. If you solve for r, you will get 28 meter. So if you do the calculation, you will get radius 28 meter. Now the diameter is 2 into 28 meter, that is 56 meter. So the displacement of the body after 6 minutes will be equals to diameter, and diameter is 56 meter. So the displacement is 56 meter. Now question number 8 for your self practice. This question is similar to question number 7, but slight difference is there. You just try to solve this one. Question number 8. An athlete completes one round of a circular track of diameter 200 meter in 40 seconds. What will be the displacement at the end of 2 minutes 20 seconds? So here total time is given 2 minutes 20 seconds. And the track is circular track. The track is circular track. For completing one round, time taken is 40 seconds. Time taken is 40 seconds. And you will have to find out displacement at the end of 2 minutes 20 seconds. 2 minutes 20 seconds, that is 140 seconds. So if you can calculate number of rounds in 140 seconds, then I think you will be able to solve this numerical easily. Question number 9, another important question. The question is, a car travels certain distance with a speed of 50 km per hour and returns along the same path with a speed of 40 km per hour. You will have to calculate average speed. In this question, distance is not given, time is also not given, only speed for forward motion and speed for reverse or backward motion is given. You have to calculate average speed. So the car moves from one point to another. While going from A to B, the speed is given here 50 km per hour. While returning from B to A, the speed is given here 40 km per hour. To solve this, we can consider, let the distance between the two positions be x. Let the time taken to move from A to B be t1, and to move back from B to A be t2. And we know the formula of average speed. Average speed, the formula is total distance covered by total time taken. total distance covered by total time taken. So we can write S1 plus S2 by T1 plus T2, average speed. So average speed is S1 plus S2 by T1 plus T2. So here we can write average speed is equals to x plus x. We have considered distance from A to B x, and B to A is also x. So average speed is x plus x, and time taken for first part T1, second part T2. So what is the formula for average speed? Average speed is x plus x by T1 plus T2. So average speed is twice x here, and T1, you know that V equals to S by T. So T is equals to S by V. So we can write here T1, instead of T1, S1 by V1, and T2, S2 by V2. So average speed is twice x by x by here. For the first part, it is x by V is 50. So we can write V1 is 50. So we'll write x by 50 plus here x by V2. V2 is 40. And the unit will be kilometer per hour. If you simplify it, you will get average speed as 44.4 kilometer per hour. First you will have to find out LCM of 50 and 40, and then you will have to simplify it. On simplification, you will get average speed as 44.4 meter per second. Now the last question for your self-practice, question number 10, and the question is similar to question number 9. A train moves from station A to station B with a uniform speed of 20 km per hour. The train then returns from station B to station A with a speed of 30 km per hour. So while moving from station A to B, the speed is 20 km per hour, and while returning from station B to station A, the speed is 30 km per hour. And you will have to calculate the average speed. This one similar to question number 9, it's easy to see. Now you can note down answers of self-practice questions that I gave you during this video. Question number 2, answer is 1.85 meter per second square. Question number 4, answer is 1.87 meter per second square. Question number 6, answer is 26.6 kilometer per hour. Question number 8, displacement is 200 meter. Question number 10, it is 24 kilometer per hour. So first you try to solve yourself, and then you can compare these answers with the answers that you are getting. So students, get ready for the challenge question. The question is, a particle moves over 3/4 of a circle of radius r. What is the magnitude of distance covered and displacement of the particle? So try to solve this answer. If you can get the answer, please send it to me in the WhatsApp number given in description. If you are among the first 5 senders, the correct answer sender, then your name may be published in the next video of the topic. We are discussing chapter motion. Today we are discussing part 3, or the video is part 3, your name may be published in part 4 in the last part of the video. So try to solve it and send it to me by tomorrow 2 p.m. Tomorrow, that means by 30th March 2020 by 2 p.m.